So it says in the last chapter, you learn how to write what's called sequential code, basically. You got 10 lines, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's not how life works. I don't know, nor do I care, where any of you live, but my guess is you didn't get in your car and drive in a straight line to get here. You had to turn and do other stuff. That's how life works. You saw this in the program that we just did with rock, paper, scissors. All right? So this chapter is talking about control structures. So they will talk about if statements, they will talk about the select case, and they will talk about 3 types, actually 4 types, of loops that you have in this language. They only discuss 3 of them now, I believe. The while loop, the do while loop, and the for loop. We've actually looked at those a little bit, if you remember, but we didn't spend much time on. All right, when you come in here tomorrow, all right, the hope is that when you come in here tomorrow, tomorrow is what, Thursday? Okay, we're probably already going to fall a little bit behind, but that's just the way it is because it's a 4-day week. Tomorrow will be lab the entire period if I get through this. Everything. I'm also going to give you for Chapter 5, the lab, all right, that you have to do. And I'm going to give you the written test. Probably with that, it's hard for me to give it to you on a Thursday and give it and say it's due Friday. So I'll probably make that due Monday. All right, just so you know. All right. So when you look in here again, Boolean expressions. What's Boolean? What is Boolean? True, false. Okay. Conditional statements mean they may happen, they may not. All right. You know, it's again, it's like if I work more than 40 hours, I get overtime. Else, I don't. Type of an idea. All right. Loops. Again, I know this is a small class, but if I had a bigger class, you know, and there were 50 of you in here, I wouldn't want to say student 1 and then do all your work, student 2, and then do all your work, student 3. I'd rather write the code once, go through a loop, and say do this 50 times. All right, that's what we're talking about. They use a future value application in here a lot, which says basically it's like if you have $1,000 and you get 3%, you leave it in for 10 years, how much money will you make when you get done? So that's what they use for a lot of their examples. All right, so Boolean again is true, false. And as they show right here, these are the relational operators. Remember, a single equal sign means assignment. Int age equals 63, that says assign the value of 63 to age. Double equal sign means you're testing something. If age equals 63 says, is the age equal to 63? So single equal is assignment, double equal sign is testing for equality. Notice for inequality, it's an exclamation point followed by an equal sign. You may or may not agree with this, but like if you ever do any work in Unix or Linux where they have that exclamation point, they'll sometimes call that a bat or a bang because it looks kind of like a baseball bat. All right, I don't know if you agree or don't agree. In some languages, not this one, but in some languages, if you want to say not equal, you do it like that. A less than sign followed by a greater than sign. Not in this language. In this language, it's always exclamation mark equal. All right? Do these make sense to people? You had them back in junior high. Greater than or equal to, less than or equal to. All right? And they give a bunch of examples in here. Okay? So, it says you can use relational operators to create Boolean expressions. Those expressions still must be true or false. If age equals 63 is either true, it's true for me, until it's not true for Keegan, as an example. Okay? So it's got to be true or false. We talked about this before, that well, let's just go on. I don't want to get off on a tangent. When you compare strings, you can only use equal or not equal. You can't say is one string greater than another. That's only for numbers. So these operations here, greater than or equal to, less than or equal to, those can only be performed on numbers. These two, equal or not equal, can be on numbers or on strings. There's logical operators. Look at them, they're right here. Remember these? We've used these at least, you use them today. 2 ampersands means and. All right? So with this example that they show right here, now let's see, I don't know why they got a single one, but this is an or as an example. So if either one of these are true, or if they're both true, it's true. But when you partner it with an and, this has to be true, and this has to be true. So and is much more restrictive, or is much more liberal. All right? If I say to Dominic, well, either you have to wear a Rankin shirt, or let's just say there were Rankin pants. You could wear one, the other, or both. But if I said you have to wear a Rankin shirt and Rankin pants, you have to have both. So again, and most restrictive or less restrictive. All right? And there's also not. Not is called an inverter. Not married is single. Not single is married. Not union means you're not a union member, etc. You can use single ones in here. When you use these, all right, it says, when you use this, I'll try to put an example up here, it'll probably make more sense. I'm going to say here, int x equal 3, int y equal 4, int z equals 7. All right? If I do this, if x is greater than, let's just say 1, or y is less than 10. All right? Just so you're aware of how this stuff works, okay? If you look up on the screen, when you use the double like this, it's called a short circuit operator. What does that mean? I'm asking you, is x greater than 1? Is it? Is that greater than 1? Yes or no? Yeah. So, since you're using the double, you never check the other side because you don't have to. So this computer tries doing the smallest amount of work that it has to do. Now, you'd say, well, if you do this one with an and, it always has to do the work, right? Well, what if we had this? Is x less than 1? No. So it never has to check the other side. It doesn't matter if that's true or false. Once that's false, the whole thing's false. Get it? If you wanted to always check both no matter what, you only use one of them. It's very rare that you're going to want to do that. They put short circuiting in because it makes the program run quicker. And typically, it's what you want to have happen. I can't say 100% of the time it's what you want to have happen. It depends on the circumstance. Okay? All right. Not only that, I should go back one. Look on the screen, please. If you've got a really complex expression, you do nots first, then you do ands, then you do ors. All right? Unless you use parentheses. So if you've got a big thing and you want to make sure it's done in a certain order, parenthesize what, notice how many parentheses I used in the last one? I wanted to make sure the system did it the way I wanted them to do it. All right? How to code if-else? All right, you can have just an if. So if the subtotal is not greater than or equal to 100 right here, what do? Nothing. That's an if without an else. Sometimes that's what you want. All right. If you're less than 20, it's voting age here. I don't know what it is. Let's say it's 18. If you're less than 18, you can't vote. There's no else. All right. Boom. You just say that. Or with an else, if you're less than 18, you can't vote. Else you can vote. Boom. All right. If you have a bunch of else ifs like they have here, it is not mandatory. An else statement is never mandatory. Never. But if you include an else, it must be put at the very end. You can't have an if, an else, and then an else if. You get an error. The system doesn't understand that. You can put an if within an if. You can put an if within an else. That's called nesting. Now look on the, on the screen here. It's kind of important. Move this. Let's see. How do I do that? There. How'd that go? You only get into this if this if is true. That's the nesting part. You could have rewritten that as if this and this. Typically, you know, when you have a nested loop, you can rewrite it as a non-nested loop. Some people love this. Some people hate this. It's just a matter of how you're wired. It really and truly is. Notice that the if statement and the else never, ever have a semicolon at the end. And if you have just one statement, look at the screen. If you have just one statement, you don't need curly braces. If it's just one statement, I always put them in anyway. It's just, to me, it's good practice to do it. It just, you know, it looks better. You tell exactly what goes with what. Guess what? We don't have to spend much time on the switch, do we? Didn't we just do that? All right. It is never mandatory you have a default statement. I talked about possible problems when you don't put one in, but it is never, ever mandatory that you have one. All right. Oh, the other thing with these, look on the screen here. Let's say we left off the word break in here. Break means get the heck out of here. All right. So can you imagine for a second we don't have the word break in here at all, and we come in and the customer type is an R. What's it going to do? It's going to set the discount to 10%. Then it's going to reset it to 20. Then it's going to reset it to 30. So if you leave off break statements, it's called a fall through. Sometimes you want that to happen. Notice we're saying here, if you're a B or a C, you get 20%. If you're a T, you get 40%. All right? So again, as always, it just depends on the situation. So they've got this program they wrote before called an invoice total. All right? And they're enhancing it. Why? To say what kind of a customer you are. If you're an R type of customer, you get, in this case, 10% off. If you're another kind of customer, you get a different amount off. That makes sense? You know, and again, when people say, I don't get it, of course you do. I've had people say, I don't get it. You go to the movies, when you're a little kid, you don't pay as much as when you're an adult, right? They usually have like maybe 3 prices, maybe free for real little kids, you know, kids price, and then an adult price. All right? It's the same kind of thing. So if the customer is an R, look on the screen, you'll do all this stuff. If the customer type is a C, you'll do all this stuff. If the customer type is not an R and it's not a C, you'll do this stuff. Again, just use curlies. It makes your life easier. All right? Now, let's look at loops. And to look at loops, I'm not going to start a new project or anything, but let's pretend I've written code here, okay? And the idea is, I may have even shown you this already, I want to print the numbers out from 1 to 10. Are you with me? So I'm going to write a quick console program. All right, I can do it, but I just don't feel like it. So I'm going to come in here and I'm going to do this. I'm going to say int LCV equals 0. LCV is my loop control variable. All right. While else, let's make it 1. We'll make it 1. While LCV is less than or equal to 10, right line, LCV equals plus LCV, LCV plus plus, boom. Does it make sense looking on screen? That's going to print out LCV equal 1. Then on the next line, LCV equal 2. And it's going to keep doing that, dot, dot, dot. Imagine I wrote 3, 4, 5, 6, 7, 8, 9. Finally, it'll write LCV equal 10. Does that make sense? All right. So there are 3 stages to using a loop. You must initialize. You must initialize the loop control variable. You must test the loop control variable. Finally, you must change the loop control variable. That's everything. All right? So that's the first one. I'll leave that up there for a second. Okay? And I'm just going to go down here. I'm just going to steal some of my code here. And I'm going to do this. When you use a for loop, it does everything together. In other words, it initializes, it tests, and it changes the value in one line. This will write the same thing out that we had here. LCV equal 1, etc. Some people like this. It's less code. Here we had 1, 2, 3, 4, 5, 6 lines. Here we had 1, 2, 3, 4 lines. This is called a counting loop. You must know ahead of time exactly how many times you're going through the loop. You have to know, or you can't use a for. Also, and I tested you on this before, but what if I do this? Question is, how many times do I go through the loop? The answer is none. Because the 11 is not less than or equal to 10, right? If I wanted to go backwards, I could start this at, for example, 10, and I can say while it's less than or equal to 0, write it, and then I do a minus minus. See that? If I was doing like a rocket, I could say LCV equal 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Then I could say blast off or something like that if I wanted to do that. This is called a pretest loop because you make the test before you get into the body of the loop. The body is within the curly braces. So if you test it before and you get in there, it's a pretest loop. This will work even if I don't know how many records I have or how many times I want to go through it. I can use a Boolean flag or something else. I cannot do that with a for. A for loop is also a pretest. Look on the screen, please. If I make that 11, see I change that from 1 to 11, I never go through the body of the loop, ever. All right? So again, pretest, pretest. I'm going to make this back to what we had before. That's typically how it's used. Now, the other thing that's kind of nice about this, this is the other loop. It's called a post test. You always go through the loop body at least once. You must, because you don't test it till the bottom. So it's always true, so to speak. So even if that's 11, even if it's 111, it's going to write LCV equals 111, then it'll fall out. So this is called a post-test loop because you don't make the test until the bottom of the loop. All right? So I've just shown you 3 ways to count to 10 using loops. All right? Of course, when you use them, it's going to be more complex than that. But there's a while loop that adds the numbers from 1 to 4. Here's a different while loop. Here's the syntax of the do while. Did you notice? Because my guess is you probably didn't. This is the only one where you must put a semicolon at the end. Never use semicolons at the end of an if. Never use a semicolon at the end of a switch. Never use a semicolon at the end of a while. Never use a semicolon at the end of the for. You must use a semicolon at the end of a do while. All right? Because I've had students ask, you know, I get it because you say that's the rules. Why do they do that? I really don't know. Somebody came up with that. All right? A long, long time ago. If you don't change the value of the loop control variable, you get what's called an infinite loop. It'll just keep going. Does it make sense looking at the screen here? If I were to have done this, if I never had that line in there, ever, it would just keep printing. LCV equal 1, LCV equal 1, LCV equal 1, LCV equal 1. All right? It would do that. Back in the days, and this is way before, you know, any of you were probably even born, when I started to do this kind of stuff, we were all hooked up to the same computer. And if you got into an infinite loop like that, it would eventually start taking more and more of the processor, and eventually you'd shut everybody down who was working. So we had to make sure that almost every time we put in a statement, you saved. Put in another statement, you saved. You kept doing that because somebody was going to bring the system down sooner or later. And I'd be lying if I said I never did it. Right? Never on purpose, but I'd done it just as much as anybody else had. All right. So again, the for, initialize, test, increment, or decrement. The while does it in multiple statements. Okay? So as it says, the for loop is useful in that it's a counting loop, and it's a little less code you have to write. All right? Break and continue. If you look up on the screen again, please. If I do this, let's get back to what we had here before. Does it all work? Yeah, that's all fine. If I come through here, don't ask me why. I'm just making this up. I'm going to say here, if LCV equal 6, break. What that will now print out is LCV equal 1, LCV equal 2, LCV equal 3, LCV equal 4, LCV equal 5, then it gets out of the loop. Break breaks you out of whatever you're in. It's severe. You saw that when we did the switch. On the other hand, instead of break, if you put in here continue, that'll print out LCV equal 1, LCV equal 2, LCV equal 3, LCV equal 4, LCV equal 5, skips 6, and do LCV equal 7, LCV equal 8, LCV equal 9, LCV equal 10. So break breaks you out of the loop entirely. Continue breaks you out of whatever iteration, whatever instance of the loop you're running. It skips that one. All right? Again, there are plenty of examples of that in here. Very similar to what I just showed you. Debugging techniques for loops. Well, guess what? You're going to learn these because we all screw up. Okay? And when you write a loop, you've seen a little of this. Do you want to write an inclusive or an exclusive loop? What does that mean? That means that we're writing a loop, and we're going to write a loop for grades. You with me? And we're going to assume that a valid grade is between 0 and 100. I can say if grade greater than or equal to 0 and grade less than or equal to 100. I'm not worrying about, well, why don't you have constants? I just want you to understand that's an inclusive loop. That'll include everything between 0 and 100. But if I write this, if grade less than 0 or grade greater than 100, that's an exclusive loop. This is inclusive with and, exclusive with or. All right? You're going to see that stuff. on your next test, you will be expected to write something along those lines. Okay? You've already done that because you've used loops and ifs, etc. when we did that first pretest that we did. So you've actually been experienced or exposed to some of this stuff already. All right, so this is that future value. That's the thing. Again, notice what they say here. If you invest $100 a month, which is what, $1,200 a year, and you do it for 7.5 years, which means you should make $9,000 if there's no interest, you'd get at 7.5% interest. I guess try that again. 1,200 times 10 years, that'd be $12,000. But if you get 7.5% interest, good luck with that, you'd make an extra $5,900. Does that make sense? So they write that program. They show you how you set it up. So here's the form. These are the names they give for everything. This is how they set everything. All right. And here then they give you the code for the form. All right. I will tell you, I don't think what you're going to do on your next test is probably that complex. But this is one of those pages, if you needed to go back and you're like, I don't think I have a program I ever wrote like this, then go back to a program like that and look at it. All right, that's it. So the next thing that we're going to do, and I'll tape this because she's not here. You two, stop listening. All right, you two, Christian, you two, please open up a window on your browser and type in vitalsource.com. Okay? If you can't read that, hopefully you can, but if you can't, oops, that was nifty. All right, you don't need the HTTP and all that other stuff. Just type in this. And I know no matter how bad your eyes are, you can read that. All right, so type in vitalsource.com into a browser window, please. It's one word. All right, and that should get you to right here. Is that what your screens look like? All right. So let's see. Yep. You want to click over here. This is actually, believe it or not, this is called a hamburger menu. Okay, you want to click on this three things here, this hamburger menu, and choose Create Account. It's not giving you that option? All right. Let me take a look at yours then, because I don't know what it looks like. Eventually want to choose that redeem that's up there because I'm going to give you, don't you choose it now, you don't have an account. So let's see. One that would actually consider it if your screen is too big. Okay, we just can't see. So just no, bookshelf, no, that would be something we have to set up an account. Library. That will be, yeah, try that. Try to see what happens. Click sign in. Okay. Click sign in, Christian. And you should get something that looks like this. All right. Under the role, make this smaller. Choose I am a student. Put in your first name, put in your last name, put in your email address. You won't be privy to things I'm privy to. I mean, you guys can do it too if you want to, but I'm not giving you codes, so you're not going to use it for anything. But if you want to do it, you can. So again, make sure you use your Rankin email, which should be your first name underscore your last name or whatever. You should know what that is by now. All right, after you put all that in, make your own password. All right. right. Notice if I click here and I choose, there's ways to get it, suggested strong password. Okay. So they'll give you one. I would recommend something you can remember. Even if somebody gets in as you, it's not going to really do very much. All right. So after you put in the password, if you want, you can read this. If you look on the screen, if you never want to get an email from them, uncheck this. I've got maybe 3 in, not just here, but I use this at the school I used to be at. I've got probably 3 or 4 emails from them in about 20 years. So you don't get a lot. You have to agree to the policy here and then click the Create Account button. All right? Remember that password though, because you'll have to when you go back to look at the book. All right, now let's see. Maybe what I'm doing isn't exactly proper, but I'm going to do it. Let's see. Yeah, I'll just do it anyway. Gotta go that. Okay. All right. Are you both in? Okay. Click the redeem button that's at the top, and it should ask you for a code. Did you hear me? It should ask you, is it? I can't hear you. I don't understand. When you put in your rank and email, it didn't take it? Do you have another email? Do you have a Gmail or something? Try that otherwise. I've never heard of that happening. You say it happened, it happened. You're in. Good. Is it asking you for a code, guys? Okay. Christian, you will put in the code that's here. All cap. Exactly as it is. Dominic, you'll put in the one that's here exactly as it is. And for Maya, when she comes, she will put in that one. Try it. That's as big as I can make it. Sorry. I can email it to you if for some reason it fails. Okay? When you put that in and click, that should give you access to that book then. See, there's not a heck of a lot of work to doing it. But if it doesn't work, let me know, then I'll make a copy and I'll email it to you, and then you can just copy it off the email. Well, then what you'll have to do, then is when you get in here, hopefully at least what's going to happen is when you go to bookshelf, that's what you'll click, and it'll have that book there. Now notice it is asking me to log in again. See that? But now once I log in, because I have access to stuff you don't, so when I go in there, it shows me different books that I have access to. Okay, did you get in? Okay. And if somebody would please try to remember tomorrow, I'm hoping Maya is back, and we'll have her do the same thing. You should now have access to that PDF copy, but again, only for it's about the 15th of February. It'll go away. You won't have to do anything. It's just when you go in there and you look, that'll be gone. It's a 30-day, and she even said she had to get special permission to do this, my rep, which I appreciate. What I'm going to do in just a moment, I've got your written test for Chapter 5. I'm going to give everybody a copy. They'll be due Monday, okay? And I'll print off copies of the lab for Chapter 5. Make sense? Next week, we'll go back. We'll be in 6, then 7, etc., etc. I'm going to go probably a little faster than Evan is. Evan, if you ever hear this tape, no slam against you. I'm giving you 2 weeks of database at the end, which I don't think that they're going to get in St. Louis. I could be wrong. All right, it won't help you three next semester. The following one it will. It'll help you and her next semester. Okay, all that makes sense? Did you get in? Can you look at the book? Okay. Did you try, Christian? Can you get into the book now? Good. Great. Terrific. Seriously. I want to make sure you've at least got access to that. All right? Okay, so I'm going to stop the tape then.